Hey guys, I'm Melanie and today I'm going to be teaching you about the neuron and it's going to be super fun, so get ready. Alright, let's get started. As you guys can see, this is the model of a neuron that I made, and it's made out of beads and string. I know what you're thinking. You're wondering if this alien-looking thing actually exists inside of our bodies. Well, it does. You also may be wondering what a neuron is and what it does. Basically, a neuron is a special cell that sends messages between the brain and the rest of the body, so that's why it's a very important cell for humans and other animals as well. So yes, this alien-looking thing helps us do everyday things, and as you can see, I have labeled everything for you. The cell body are the blue beads, but the dendrites are also a part of the cell body, and they consist of the red beads, and the yellow bead in the center of the neuron represents the nucleus of the cell body. Then you have the axon, which are the orange beads, and the axon terminal, which are the white beads. Now that we have that covered, I'm going to teach you how a shock travels through the neuron. Learning this process is important because this is how information gets transferred from one neuron to the other, and this is how we process information inside of our brains. The main sections we are going to focus on are the cell body, the axon hillock, which is basically the starting point of the axon, and the axon terminal. You guys are going to be experts on the neuron by the time this video is over. Isn't that exciting? Anyway, the first place we are going to look at is the membrane of our neuron. So this is my model of the membrane of a neuron, and as you guys can see, it is also made out of beads and string. We also have some marbles as well. The middle part right here is the membrane. This is the outside of the membrane, and this is the inside of the membrane. So this is outside the neuron, and this is inside. On the inside of the neuron, we have protein and potassium, which are the green marbles. And on the outside of the neuron, we have sodium, which are the blue marbles, and chloride. Basically, the function of chloride and protein is to hold charge, so they're not going to be major players in this process, but they're important, so they need to be represented as well. But don't worry about those too much. These four green beads right here represent the potassium channel, and these four blue beads right here represent the sodium channel. And these four red beads represent the potassium-sodium pump. Now I'm going to explain what the membrane does when the neuron is in its resting phase, in other words, when it's just kind of chilling out. So in the resting phase, this potassium channel opens up, and the potassium leaves the neurons because of diffusion. So these green potassiums are going to go across this potassium channel, like so. These potassiums want to spread out from each other because they want their own space, and that's what diffusion is. And once these potassiums leave the neuron, this potassium channel closes, and this process gives the neuron a negative 70 millivolt charge. So that is basically what's happening in the resting phase. Let's go back to the model of the neuron very quickly to see what happens when a neurotransmitter comes in contact with a dendrite. So the beginning of a shock starts when a neurotransmitter, this little blue bead right here, hits the dendrite. That was a terrible throw, but you guys get the idea. So basically, when that little blue bead that I just threw hits one of these red dendrites right here, it causes a change in the membrane of our neuron. But before we return to the membrane, let me explain what a neurotransmitter is. Basically, it's a chemical that transfers signals from one neuron to another neuron. So again, these neurotransmitters are important because they help our brains to process information. So now we are back to the membrane, and now we are going to see what happens when that blue neurotransmitter bead hits that red dendrite bead. The action of the neurotransmitter hitting the dendrite causes the sodium channel to open. So this sodium channel right here is going to open. So all of this sodium, these blue marbles, are going to rush into the cell. Like that. Because of diffusion and ionic force. Ionic force means that these sodiums are attracted to the negative charge of the neuron because sodiums have a positive charge. You've heard it before, opposites attract. Sodium rushing into the neuron creates our shock, or a bizz, and changes the charge of a neuron from a negative 70 millivolts to a positive 40 millivolts. Then after this occurs, the sodium channel is once again going to close. After the charge or shock is created, we have to get our membrane back to its original state. So once again, this potassium channel opens, and the rest of this potassium is going to leave the neuron because of ionic force. And once again, the charge of the neuron is back to a negative 70 millivolts. But now we have a problem because all of the potassium is outside of the neuron and all of the sodium is inside of the neuron. And as you guys can remember, when the neuron was in its resting phase, it was the other way around. All the sodium was outside of the neuron and all the potassium was inside of the neuron. So that's where our potassium-sodium pump comes in. This pump is going to exchange 1 sodium for 1 potassium. So 1 sodium is going to go over there, 1 potassium is going to go over there. Like so. And now the neuron is back to its resting phase, and now it can go through the shock-making process again. This is important because the neuron needs to produce shocks very quickly. Also keep in mind that this process is happening all over the cell body. So now that we have created our shock, let's look how it's going to travel through the neuron. Our shock is going to be carried by sodium, and then it is going to travel to the axon hillock. Just so you guys know, the axon hillock is the decision point. This is where the shock is going to decide whether or not to travel along the axon into the axon terminal. It's important to note that this can only happen if the axon hillock reaches a charge of negative 55 millivolts. So let's zoom in on this area of our neuron. Now, as you guys can see, there's a bunch of sodium, these blue marbles, and sodium channels, these blue beads, inside of the axon hillock. This yellow area in the middle here is called myelin. Myelin is basically an insulator, and it's going to cause our shock to move very quickly through the axon. Remember that all of this sodium is carrying the shock that was created in the membrane. So all of this sodium is going to flow through the sodium channels, and then it is going to flow through the myelin, like so. Missed one. Remember that this is happening at a very fast speed, and this myelin makes it appear as if our shock is jumping down the axon, but in actuality it's just the breaks in myelin that makes it appear this way. So this is what is happening in the axon hillock. Now let's look at what happens in the axon terminal. Only one more step, guys, then you will be experts on the neuron. So now we're back at the model of the neuron, and as I just showed you, the shock is going to travel from the axon hillock along the axon into the axon terminal. In the axon terminal, there are these vesicles that hold neurotransmitters. These vesicles are made by the nucleus, and the neurotransmitters are obtained by the synapses of the surrounding neurons. You may be wondering what a synapse is. A synapse is where the communication between neurons takes place. So this is where the neurotransmitters that are being held by the vesicles are going to transfer from neuron to neuron, and this is how our information and signals travel throughout the brain. So let's zoom in on the axon terminal and see what happens in the synapse. So here's our axon terminal. So our shock is going to hit this vesicle, and it's going to travel all the way to the synapse. This section right here is called the synapse, and multiple things can happen once we reach this point of the neuron. One of these neurotransmitters right here will hit the receptor on another neuron, and this will start the shock-making process all over again in another neuron. Okay. One of these neurotransmitters will be taken up by the reuptake channel. This saves energy and uses the neurotransmitters again and places them in vesicles, and this is important because cells want to be efficient with their energy. One of these neurotransmitters will be eaten up and destroyed by this yellow enzyme, because we can't have a bunch of neurotransmitters in the synapse because that causes confusion and causes mixed signals to be sent to other neurons, which causes a variety of problems. And then one of these neurotransmitters may hit this purple autoreceptor, and once that happens, it shuts down the whole process, and that stops the shock from being sent to another neuron. So yeah, that is what is happening inside your brain. Keep in mind that we have billions of neurons inside of our brain, and they are arranged in a complex network, and that this process is constantly happening. And now that you guys are experts, maybe you can teach other kids your age about the neuron, because the neuron is very interesting, and it's a very important and essential cell inside of our bodies. I hope you guys learned a lot, and that my models were helpful in understanding all of this information. Have a great day, and I hope this got you excited about the brain.